we're finished. So welcome everybody to December's StaPH-B call. So I was just talking to our panelists and the people who are going to be presenting on this call before everybody kind of joined. And I was just telling everybody how nice it is to have kind of a change of pace a little bit from the craziness of COVID and the world that we are all kind of dealing with. And I feel like in StaPH-B in general, we tend to focus a lot on kind of the infectious disease aspect of bioinformatics and public health, just because I think that that is where a lot of us kind of work routinely. And that's kind of where a lot of our interests lie. And especially, you know, in a pandemic, that is where a lot of our efforts are going towards. And so I think it is nice sometimes to kind of step back and have a little bit of a widening of the scope of everything else that happens in bioinformatics. And, you know, this is something that I had been really hoping to kind of get together for a little bit of time now, was kind of a little bit of like, I guess, a primer on newborn screening bioinformatics, because I think that it's a whole new set of challenges and kind of responsibilities and things that go into this particular aspect of bioinformatics in the public health world. And we don't always get exposed to it on the infectious disease side. And so I think that it's really great to kind of bring us all into the fold and be able to explore some new topics. So with that, I think Gretchen is going to be driving the slides, but I can go ahead and turn it over to our newborn screening colleagues to introduce themselves and to start going. So welcome and thank you so much for giving this talk. And just everyone, I think your mics should be muted as you come in, but if you notice that it's not, please mute yourself. And if I notice some background noise, I'll try to monitor that as well. So thanks.
Cool. So I guess we can start with introductions here. So my name is Gretchen Cote. I am the newborn screening bioinformatician here at the Virginia Division of Consolidated Laboratory Services. So same lab as Logan and Rachel here. Y'all know them, obviously. But yeah, I've been at DCLS for about 4 years now. I actually started in infectious disease and gradually transitioned to newborn screening, where I've been for maybe 2 to 3 years of that time. Yeah, so that's a little bit about me now. You will learn more about all of us throughout this entire presentation.
Hi guys, the name is Jessica Respress. I am the APHL Newborn Screening Bioinformatics Fellow here at New York State's Wadsworth Center. I started January 27th, 2020, so right before COVID hit. And so I got sent home for a couple of months. And in that time, I got to learn all about newborn screenings and the stuff that I'd be doing as a fellow. And it's been 2 years now, and my fellowship is about to end in January. So it's coming up, and I'm excited to talk with you guys about all about newborn screenings.
Hey guys, I'm Miss Marcellus. I got my MPH in Epi, specifically genetic Epi. I just finished my newborn screening bioinformatics fellowship in September, and then I transitioned to a full-time role in our lab. We do like a core bioinformatics system, so I help out with COVID, but I primarily focus on newborn screening. There's 4 of us. We kind of all back each other up and rotate around. So I've been here total almost 3 years now.
All right, and Jessica's going to give a little introduction to like laboratory newborn screening as a whole, just to kind of get the conversation started.
So yeah, an introduction. Though we all have a newborn screenings lab in each state, there are some key differences that you might see. And each difference can be separated into categories, and some of which can be based on different things. For example, our newborn screening panel, it can be a little bit different in each state, and that can be based on state laws, financial considerations that we have to consider, and then how frequent a disorder might be seen or be prevalent within the population of your state. Some methodologies are also different between each state. For example, some states like to send out specific screening panels to another state for results, or they will hire someone commercially to give you results as well. Sometimes the screenings or the tests that we use can differ by, for example, using mass spec versus digital microfluidics. There's also a difference between like some states using Sanger sequencing versus next generation sequencing, though there's only a small group of people who do that, or no sequencing at all. And of course, there's the cutoff values, which is also based on your data set, which can be determined by your population as well. Other states have one screen versus two screens. Also funding sources based off what the state give you versus the grants that you're able to obtain vary by state as well. And RUSP, or Recommended Uniform Screening Panel, is decided by different categories based on, for example, how accurate you are able to screen for that disorder, how much that disorder might cost, and other variety of things that actually help to determine whether this screening panel will be, or the screening test will be added on to the recommended screening panel as well.
Yeah, and I guess to add to that a little bit too, so babies in each state, the tests are collected just after 24 hours of birth and get sent to the state lab. So when we talk about a one screen versus two screen state, and Sam, you guys are a two screen state, right?
Yeah, so we're a two screen. We collect the first one 24 to 72 hours after birth. Usually we try to hit 24 hours. And then our second one is collected anywhere from 7 to 21 days after birth, usually your like second pediatrician checkup.
Yeah, and so Virginia and New York as well are one screen state, and we collect that first card just after 24 hours. And, you know, just by those different methodologies and approaches, our algorithms for which samples go to which test and our thresholds, they vary sometimes pretty significantly, just because of the days in which we are performing the testing on the samples and whether or not it's that first card in a two screen state, or a second card in a two screen state, or just the only card. A lot of one screen states too, we rely heavily on like repeat cards. So if we have borderline results, depending on the assay, we'll ask for a second card to confirm the results on that first card. Yeah, but in each state, I think Jess said this, but most states seem to follow that RUSP, the Recommended Uniform Screening Panel, but other states can add them on, do variations. There's primary disorders, which are the target of the screen itself, but we also sometimes list secondary disorders that we I guess kind of identify through the testing associated with that primary disorders. Yeah, so bioinformatics and newborn screening is kind of why we're all here, to kind of talk about what we do in terms of bioinformatics. So it's very new, and I think a lot of us who are in the newborn screening bioinformatics kind of always have this question of how many are there of us, because we're kind of few and far between. So this past July, we actually sent out a survey asking states with newborn screening bioinformatics, and you guys probably saw that survey pop up on the StaPH-B Slack channel, us trying to find state newborn screening bioinformaticians just wherever they might be hiding, because I think we all know that bioinformaticians hide. Or a lot of times they don't know that they're doing bioinformatics until they're like, wait, that looks like me. So also on this call, if you are a bioinformatician working in newborn screening and you haven't been in contact with us, please reach out to us. We want to know who you are, and we want to keep building that support for our community. But
really
yeah,
nice.
so
we're not scary.
Yeah,
we promise.
Exactly. So, but yeah, in that survey, we tried to ask people like about their role. And because newborn screening is so diverse, the role of a bioinformatician in newborn screening is also very diverse. So what we kind of learned about that was that while there are many states that are currently sequencing, they differ greatly in targeted disorders and methodology. And that's, there's kind of some lack of standardization in newborn screenings because it's all separate programs. And like I said, newborn screening bioinformatics is new but growing. I think we saw the longest supporting bioinformatician has been in their role for 5 years. And I think that's Bob in New York, I don't think he's on the call, but Jessica works with him closely.
A lot of hats here, so he's always running around.
Yeah. But since that time, you can see that we have grown to 4 states in the country now with a dedicated bioinformatician, and 2 additional states with a bioinformatician in more of like a shared role. And as a community, we have been trying to have more engagement with StaPH-B. A lot of us are involved in varying capacities. This is our attempt to kind of continue to grow that involvement. And really important to growing newborn screening bioinformatics is the APHL-CDC Bioinformatics Fellowship for Newborn Screening, which first started for us in 2019. Both Sam and Jessica are part of that. And it's been really great for growing our program. So I guess we can talk a little bit now about our individual states and our newborn screening bioinformatics programs in our individual states and how it's kind of grown. So in Virginia, where I'm from, like I said, I transitioned from newborn screening to newborn screening from an infectious disease about 3-4 years ago. And at that time, we didn't have a computing environment. We were just beginning talks for our first sequencing-based assay. I was doing all of my bioinformatics on my own personal computer, but which I think, may sound familiar to some people, but today we have on-site scalable computing resources, and we're working to expand sequencing capabilities from Sanger to next generation sequencing. And currently we have 2 dedicated newborn screening bioinformaticians, me and our new fellow, Christian Alcorda. But I guess, yeah, so I guess for Jessica and Sam, if y'all could kind of talk about how newborn screening bioinformatics has expanded at your state laboratory since its implementation.
Yeah, I can go next. So we have been doing Sanger sequencing in-house for a few years now. We're doing Sanger sequencing for X-linked adrenal leukodystrophy or XALD, the hemoglobinopathies, and VLCAD. It's like very long chain fatty acid disorder. And we're doing all of those on Sanger right now. And 3 or 4 years ago, they got a grant to buy a MySeq for newborn screening, and we're planning on doing a SCID, severe combined immunodeficiency, which is like bubble boy disorder. We've been trying to do like a 39 to 55 gene panel for that. I'm just stealing Jess's fellowship project whenever if she finishes that. We're just gonna do that here when she's done. And when I got here almost 3 years ago, we had no infrastructure for infectious disease, no infrastructure for newborn screening. So my whole fellowship was just building infrastructure. So now we have 6 semi-static AWS instances, 4 for infectious disease and 2 for newborn screening. I'm like 90% newborn screening, and we have a new biometrician we hired starting in a few weeks that will join me in newborn screening. And then our 2 infectious disease bioinformaticians also help me, and I keep them up to date on newborn screening if we were to need it. We're looking at in the next 5 years moving towards whole exome sequencing with some intronic panels, and then just masking what we don't want to look at or aren't approved to look at, similar to what Utah is trying to do right now. So we're also kind of following their lead. It's interesting because like the diseases that we're sequencing aren't anything that's like even on Gretchen's radar for Virginia. not what New York's doing. So it's very state by state. We're the only people doing VLCAD and hemoglobinopathies. So we're kind of on our own on that one.
Yeah. I think like a lot of like with states and what they're performing sequencing for depends a lot on like their state specialists and what kind of information they want and need in order to make the best decision and what they feel like will shorten what we call is that diagnostic odyssey, the length of time from you know, birth to receiving a diagnosis for an individual with a disorder.
And whatever parent advocacy groups you have in your state.
Yeah,
so like Krabbe disorder is a disease that's not on newborn, it's not on the recommended uniform screening panel, but it is screened for in a handful of states because one of the Buffalo Bills players' kids died of Krabbe, and he had a lot of money to throw into advocacy. So he really pushes for that to be on newborn screening. So it's a lot, it can be more political than infectious disease.
So
yeah. How about you, Jess?
I would say there's a nuance to New York when it comes to transitioning from Sanger sequencing to next generation sequencing. Before I came, I think for a couple of years, specifically for cystic fibrosis, but Bob had been working on a third tier for it using next generation sequencing. And we actually have a core facility, I think it's called AGTC, where a lot of the samples are sent and library prep there, and the results are sent back up. And then any variants called would be validated or confirmed, whether it's like pathogenic or benign or stuff like that. So he has been working on that for like 5+ years, I believe. And then within the last couple of years, they transitioned to progressing the next generation sequencing into something like SCID, for example. They had a 39 gene panel with a pilot study done. And yeah, I think for me coming in, something happened with the technology that they were using where the reagents they wanted, they no longer provided. And so they had to transition into using a different type of technology. And they thought that since they were already using Archer analysis for CF, they thought it would be an awesome idea to try and transition that into SCID. And along with that, add on a couple more genes that they found in papers and such. So it went from a 39 gene panel to a 55 gene panel. And yeah, that's where I came in. So right now I'm validating a 55 gene panel next generation sequencing for SCID, severe combined immunodeficiency disorder. And it's a very big panel. When you compare it to Bob's cystic fibrosis, which is just one very big gene, there are a lot of nuances when it comes to what I'm doing. So I've been taking what he's done, but also having to figure out some things on my own. And that's been a fun, nice adventure. So Sam, you're welcome.
You're the best.
But there has been a hiccup with, I think, with COVID happening where the core took priority for those samples and didn't really consider my samples to be considered priority at all, since I'm just a researcher. So when I came back, luckily our director, Michelle Kajana, had put in a grant for idiopathic T-cell lymphopenia. And with that grant, she was able to buy us a MySeq. So I actually had to do a lot of training on my own and setting up different labs for library prep. And so now, instead of sending the samples that Bob used to do, like pretty much extract the samples, send them to the core, they bring them back and you analyze it. I actually have to extract the samples, do the library prep, load the MySeq, and then analyze it myself. So it's like, yeah. So that's been my experience here at New York, but it's been fun. I've learned a lot.
And just, do you want to take this slide?
Sure. So
yeah.
I've already mentioned before, my experience of being a newborn screening bioinformaticians, you have a lot of diverse responsibilities when it comes to doing your job. For example, Bob, I I feel bad bothering him sometimes because he's not just like sitting at the computer analyzing or setting up stuff. He actually has to, he actually plays other roles within the lab and is more involved. So for example, with the CF panel, once he got that established, he actually had to train other people in understanding how to analyze the data and also the DNA extraction process, how to send it to the core, all the paperwork involved in sending it to the core. And also when it comes to the interpreting everything, the whole thing, he had to actually put it in writing and actually it was able to train people on it. But that's just, he doesn't just do that. He runs over to mass spec and helps them out as well. And then, yeah, so when it comes to the diverse responsibilities, you have interpretation and report generation. There's administrative work and education that you're responsible for, computational development and research. It's trying to find, if you are given the opportunity to research some type of next generation sequencing, something, and reading up on papers and such, and trying to finding all the right tools and connections that you need to figure out those things, actually validating and quality control, which is something I'm doing right now, and then wet lab bench work. That's like pretty much the whole thing. It's a lot of stuff.
Yeah, I guess, you know, we can kind of talk about what a day in the life of us as newborn screening bioinformaticians is like. But for me personally, like, you know, as Jess said, I have my hands in a lot of different areas and many that I would have never expected from a job as a bioinformatician. And I think a lot of us feel that way. In programs or areas where we're working to build something. You know, in Virginia specifically, up until a certain point, we have, despite our best efforts, has kind of been a little siloed in terms of our newborn screening bioinformatics and infectious disease bioinformatics, but we've made a lot of work to try to join things up and now are, you know, a cohesive group. You know, we work towards kind of supporting each other in that sense. I, like a lot of us, do a fairly good amount of time sitting behind a computer. I don't do any wet lab work. That is not my area. You know, I spent a lot of time working on development of existing and future bioinformatics analysis solutions, pipelines. We're currently evaluating adding on NGS pipelines or panel-based pipelines targeting multiple genes. So, you know, a lot of the work for transitioning from Sanger to next generation sequencing involves discussions with higher ups, education on what the capabilities are, what benefits it can add, how does it support our community, adding on this additional technology. And so I do a lot of education and communication, but then, you know, I also spend a lot of time just writing and building scripts and applications. I think, I don't know if other labs have this experience, but in newborn screening, there's a lot of, I guess, really heavy manual analysis that's done at different parts, or, you know, there's Excel macros that they've written in the past that have been sitting around that someone wrote and they rely on. And so a lot of what I do is also kind of looking at analyses that can be automated and standardized and brought into a more, I guess, efficient and updated language. And so I do a lot of work with that too, as well. And also I lead our variant interpretation efforts under the supervision of our director. And we have custom built bioinformatics pipelines that support that we have, that we rely on. Yeah.
Yeah, my days are very similar to Gretchen's. Like, I only go into the lab on Tuesdays, so there's no wet lab. It's mostly sitting in front of my computer on committee calls, trying to corrupt the EPIs of the state into getting involved into newborn screening. And I'm now in charge of our Texas Epi social media. So there will be a lot of newborn screening happening. But I think with Gretchen too, the big difference between like our infectious disease bioinformatics and what I do is a lot with the variant interpretation. Because for like COVID, you run your pipeline, you get that it's a Delta or an Omicron, and you're like, all right, that person has COVID. Like that's not how newborn screening works. With a lot of the mutations, like for some diseases, you'll need 2 mutations, one from mom, one from dad, in order to get disease. And for some diseases, you only need 1. And for some, it has to be in the X chromosome or it has to be in the Y chromosome. And sometimes even when you have 2 mutations, they don't cause any problems. So you're still, it's benign and completely normal. Most of the time it ends up being like a variant of uncertain significance. And then you spend 6 hours looking at literature, trying to figure out what it means. So that's a lot of what Gretchen and I work on, is creating pipelines to make that part easier and that part quicker, because you can spend a full day on one baby's variant interpretation before you even send it off to the geneticist, who will then do their own variant interpretation.
Yeah.
So that's like our big step in the process right now, and then like our geneticists too, like when I worked with the Iowa newborn screening program, there were 4, they all sat in the same hallway. I could just go talk to them. But here I work in Texas and we have geneticists, it feels like on every corner, who have a different opinion about everything, and what they want on a report and what they don't want on a report. So I think that's been the biggest difference, is the variant interpretation.
Yeah, absolutely. Ooh. All right, so we can kind of talk, we'd like to talk a little bit about planning for expansion of newborn screening molecular to on-site sequencing, and kind of some of the options and considerations for different states. So one of the questions I think every state asks when looking at moving to sequencing is, what is applicable to expansion of molecular to sequencing. Sorry, 1 second. All right, so and a lot of that is looking at additional disorders on the horizon. So a lot of those, it varies by state. So in Virginia, Krebe isn't currently on our panel, but there's discussions about adding it. So a lot of times we look to see what types of disorders are in that pipeline and whether or not sequencing would provide some benefit to that disorder. There's also a whole host of disorders associated with the mucopolysaccharidosis. There's like type 1 through, I don't know, does it go to 9? Sam, you might know.
It goes to 9, but there's no 7, because that makes sense.
Yeah. So, and those aspects are, whenever we have the opportunity to evaluate a new disorder, I think now with the advent of sequencing, we will ask the question of would sequencing benefit this assay? Additionally, there's the addition of new tiers. So a great example to this is, we've been screening for cystic fibrosis. States have been for, I guess, 20 years-ish, maybe roughly. But the first tier test has a high false positive rate. So states have worked to kind of bring on a mutation panel. I think that varies from looking at one variant to, I think there is a 139 gene panel. And then, states can look at adding on that additional second tier. And now with sequencing, a lot of us are looking at or have already brought on additional NGS to follow, some of these databases and groups that really work on variant interpretation. So states can kind of look to adding additional tiers onto disorders. And what that kind of does, it allows us to kind of narrow down and reduce our false positives. So I think cystic fibrosis has a carrier rate of like 1 in 20. So that means that for states that are just looking for one mutation, they're potentially reporting a lot of carriers for sweat testing. But adding on additional tiers and looking at for new or expanded mutations allows us to kind of increase that sensitivity and specificity of our tier and narrow in that net they're casting, and try to, I guess with every tier we're adding, we're trying to reduce the number of false positives, which false positives just have significant stress to families and their ability to bond with children. So yeah, and then also there's developing on-site capabilities. Many states, especially with cystic fibrosis, there is, I think, states that are looking to expand their mutation panels. They will send out to commercial labs to perform that sequencing for it. So states looking to expand their molecular sequencing can look at bringing that testing back on site. It allows you to kind of have a little bit more control over the variants you can look at, which allows you to expand it as the community's understanding of variants also expands. And also kind of, I guess, yeah, I guess the main is to have the testing, the control over the testing to expand it as you see fit, to make sure that it's not stagnant. And then also replacing existing assays. One of the things that we're thinking about in Virginia is we're currently doing Sanger sequencing for a group of disorders called lysosomal storage disorders. And, you know, as we brought this on, our sequencing load is much greater than we ever expected and is actually more suitable for next generation sequencing than we originally thought. So, you know, when expanding to sequencing or next generation sequencing, you can look at how sequencing can improve your turnaround time of your existing disorders. Because we don't want to add on technology that adds weeks onto the turnaround time and getting babies answers, because the longer it takes us to get answers on a sample, we all have to remember that there's a family at home that's worried, waiting for answers. So
I just
a
want
lot
to
of
add
that
something,
is,
if that's
yeah.
okay. So for
Me
like,
too.
especially when we talk about adding on panels, we're not talking about the same panels for every state. Because for like, for cystic fibrosis, some states are only sequencing like 4 or 5 mutations on that gene, whereas like Wisconsin's is like 323 mutations. And it's not appropriate to do that many for every state, because like Wisconsin has a huge Amish population. So they have a lot of Amish specific mutations. Or like when we worked with South Dakota, they had one CF mutation that's only seen in one small part of South Dakota and nowhere else in the US. So like that was part of our custom panel. Whereas in Texas, we have basically no Amish populations. So we don't have to worry about that at all. So it's more complicated than a lot of just like states, everyone using, like for Jessica using the CF panel, it was like, oh yeah, no, we're gonna, or the SCID panel. Yeah, we're gonna use that for now, but then we're also probably gonna add our own.
Yeah, it's each state has such a diverse population. So, you know, what works for one state definitely might not work for another state just by, you know, the makeup of people that live there. Yeah, absolutely. And then, you know, for newborn screening, we all have this conversation of, you know, well, what do we consider when bringing on sequencing? And every one of these considerations plays a huge role in the process, from that initial decision-making to implementation. And I think we all know that even though once you've considered each one of these and met them once, that's it. But that's not the case. We continually evaluate each one of these items, and look to see how we can expand them and readdress each item, even throughout the, I guess, life of a screen. And so, yeah, so for when we started Sanger sequencing, it was requested as part of our LSD screening. And our consideration for that was, you know, we were again trying to reduce our number of false positives. LSDs have something called pseudodeficiency alleles, which result in abnormally elevated or abnormally low enzyme activity specific to our assay and our synthetic enzymes, but it doesn't, those variants in particular don't result in disorder in the body. So these babies look like they screen positive for these disorders, but they actually don't. So sequencing allows us to look for those very specific variants and filter those babies out and not refer them for additional testing. But yeah, so when we were looking to bring that on, or any state is looking to bring that on, we kind of have to consider leadership buy-in. So that cost versus benefit relationship, that reducing false positives and false negatives, and in turn kind of shortening the diagnostic odyssey. I think with a lot of these disorders with high false positive rates, there's kind of a desensitization that happens with them. So which in turn, hand in hand, can result in a longer time to diagnosis for those with a true disorder. So there's a really big push to reduce false positives in order to make sure that when results come back positive or abnormal, that PCPs and families get moving. When bringing on sequencing, we, like everyone, have to consider expertise. So the wet lab, the dry lab, support of your IT group. And genetics plays a huge aspect. I think every state differs in what kind of genetics support they have. Some have internal geneticists within their laboratories. A lot of us, Virginia specifically, we have hospitals and geneticists that are contracted to work with the state newborn screening program. And so we consult them on all of our decisions, but even still, you have to have the expertise internally when considering things like variant interpretation. You know, that happens before we even send results to the specialist. A lot with newborn screening sequencing, we have to assess that needed throughput. It varies by the disorder, what kind of throughput you're looking at, and it's not standardized. And you know, you have the number of babies that are coming in through your state and born every year, but only a small portion of those will need to be reflexed to a sequencing assay, and that load will vary by disorder and you know, how accurate your first tier assay is. So for example, we initially estimated our lysosomal storage disorders to reflex 8 babies or samples a week to sequencing. It ended up being something more closer to 20 to 30 in summer months, and it got as high as 60, winter months, and it got as high as 60 during the winter months. So one of the considerations is, how do we handle variations in sample load and throughput? And then we, like the rest of, or infectious disease bioinformatics, has to think about our computing environment. We have that, you know, not added responsibility, but increased concerns about security and privacy. Different states are at different points when it comes to cloud computing or local computing. Virginia went in the direction of local computing resources, but Texas has worked towards cloud computing. Yeah, and of course, you know, like I said, that ethical, legal, and social implications discussions become more complicated with the addition of sequencing. You have the issue of consent, and when it comes to variant classification, what do we do if we report a variant of uncertain significance and we, down the road, more information is added where we now aren't uncertain about that classification, but we are able to say this is likely benign, or now we have evidence saying it's pathogenic. It kind of changes the timeline of newborn screening, and it's something that needs to be considered, is how your state plans on handling that if you plan on reporting reclassifications. It kind of falls into the whole amended report category, but you know, sometimes amended reports are looked from the perspective of it's a correction of your original results, but in this instance, it's not. You made your original, you reported results originally according to the information that was available to the community. And since that time, that information has expanded. So yeah, and then, yeah, okay. All right, and Sam?
Yeah, can you go to the next one, please? So I'm just going to talk about some of the like similarities and differences between infectious disease and newborn screening, to give you guys ideas for like places to start to talk about with your internal team and places you might be able to lend expertise as programs are getting built. So similarities is that the skills are pretty transferable. We're using Python, we're just using shell scripting. It's the same, we're using MySeq a lot of the time. If you're using Sanger, that might be a little different to work with than you're used to, but we want to get everyone on next gen, so that might be a good place to start. Theoretically, we can use the same computing environments. Our AWS instances and S3 buckets are similar but different because newborn screening involves a lot of PHI that infectious disease doesn't. So we have a little more encryption involved, a little more security, but it's basically the same. But we don't let our infectious disease folks have access to our newborn screening and vice versa. Jess, do you want to say something?
Yeah, we don't use the cloud here.
Yeah, I think that's a complicated topic for newborn screening.
I'm best friends with our lawyer now. We use the same tools for QC, cleaning, and alignment, same tools where you can still use Bowtie or BWA, but we don't as much. So it's fairly similar. You can use whatever tools of choice you would like to use. The variant calls are different because it's human versus pathogen, but the output is in the same file formats. It's a VCF file. It looks fairly similar. So it's pretty easy to read. Like our infectious disease folks haven't had any problems looking at my files or my pipelines. And then I'll show a map on the next page about how we're also split into 7 regions for support, but 7 slightly different regions. And we also utilize NCBI. So like I'm able to use my NBS access keys for infectious disease. We just use a different page. We use ClinVar for clinical variants instead of SRA and GenBank. We don't upload our newborn screening stuff though. Okay, the next slide, please.
Yeah.
So these are our maps for the regional networks. The newborn screening ones have really long names, but they're pretty similar. There's just a couple of differences, like 1 or 2 states per region are different. But for the most part, you can reach out to whoever you think you could get help from. Like just Gretchen and I text all the time with Bryce and Nicole in Utah, reach out to them for help. And it's like StaPH-B where you just get help wherever you can get help. But like we use Utah a lot because they're a regional resource for infectious disease. So they've also been able to provide some support for our newborn screening group. And I couldn't find if the Virgin Islands or Guam are involved in PulseNet, but they are newborn screening. Puerto Rico has a fantastic newborn screening program, and they present a lot of data. So they're a good resource too. Yeah, the next one. And so here are some of the bigger differences. So for infectious disease, you guys are all on NextGen. For newborn screening, some are on NextGen, some are on Sanger. Us and I think New Jersey use both. Would not recommend using both, but it is what it is. For infectious disease, mostly all states are sequencing or sending out to some capability. For newborn screening, there's about 10 of us. Most are send out. Infectious disease, you have PulseNet, you're mostly doing the same pathogens, got your E. coli, your salmonella, your COVID. For newborn screening, it's all over the place. There's about 10 diseases that are being sequenced, but most of the new conditions being considered for the rest will require some sort of sequencing, like Duchenne muscular dystrophy will be up there with sequencing as more gene therapies and like CRISPR gene editing technologies, as those get approved, gene sequencing will become more important for newborn screening. When they put a disease on the RUSP, they don't really tell you how to screen for it. Most people do the same thing or do the same similar molecular testing, but gene sequencing's really up to you. And then we also have the legislative involvement. Some states will be, you have to screen for everything that's on the RUSP. Some, every time you add a new disease, you have to go back and get a legislative mandate. Or like Virginia, you guys got screwed and they're like, you have to screen for this immediately. Have fun.
Yep.
But
yep.
There's a lot of,
that was our
and it
first
doesn't ever come with
essay.
money. Yeah. There's never money. We have PHI, a lot of PHI. A lot of states have very specific newborn screening data privacy laws. We can only keep samples for 2 years and they have to be destroyed, because we got sued one time. I know Wisconsin got sued, so now they have very strict data laws. For the whole exosome sequencing samples themselves, like COVID's 30 genes, it's pretty small. The human whole exome's like 10,000 genes. It's kind of crazy. Like just for SCID for one disorder, we're doing 55 genes, so it can be a lot. And the number of samples per year is much larger. We do in newborn screening, we do about 5,000 infectious diseases samples per year pre-COVID, and we do 1,200 a month for newborn screening. So it's a lot more, and that's just with the diseases we're currently doing. And then for infectious disease, you guys do a lot of surveillance efforts, wastewater testing. You can just go do like COVID surveillance to see how much COVID's in the community, do air testing. There's not really surveillance options for newborn screening. You're not going to put a baby through a test just to see if they might have something. And you can't really use any sequences or any samples you have for surveillance efforts. You're left with just using epi methods for what you have. And then it's an opt-in versus opt-out. For infectious disease, you normally go to the doctor because you're not feeling good. They'll do some sort of test. Newborn screening, it's all babies. But for like newer conditions or pilots, you have to specifically opt into that. Whereas for the regular newborn screen, for most states, you have to opt out. In Nebraska, you're not allowed to opt out for any reason. Like they will send a sheriff to your house to do it. So that also goes by state.
Yeah, now I would add, just with the limited surveillance options, that states typically have very specific limitations to what they can and can't do with a sample. Piloting disorders is really, for Virginia, we can't do that. We can't pilot screening for a disorder. So when we go live for a new disorder, we go live. We can't test it out before and kind of troubleshoot. When it comes to like, we can't use our samples for QC. Let's see. Yeah, I think those are the major ones that I was thinking of. So it's, you have specific rules for how you can use babies' blood spots and how you can't use them. And I think sometimes that just makes things tricky for gaining information on our wider population for the benefit of the population. So, but you know, there's reasons why there's those limitations, and those reasons are very valid. So it's tricky.
Yeah, ours is pretty similar. Parents can opt in to having their kids' samples used as positive or negative controls. Most kids who have a disorder, their parents are generally down for research, so they'll let you use their samples for positive controls. But for negative controls, we normally use our lab staff, except for me, because I'm paranoid. I'm like, you're gonna find some weird disease. Nope.
Yeah. And then that is huge. The opt-in versus opt-out is huge as well.
Shout out
Virginia,
to the nurses. Most of the nurses.
They have to do, you know, that point of contact is with parents. Virginia, we're opt-out, and there's really no point of contact other than with the nurse, where they get permission, or, you know, I think education really only happens if there's concern and if a family's leaning towards opting out, and then they kind of step in and start talking to families. So yeah.
And like on the weekends, we didn't have enough nursing staff in Iowa, so we had iPads that gave them stuff.
Yeah.
And I was just gonna say, like, for infectious disease, it's normally you talk to CDC Advanced or Office of Advanced Molecular Detection, whereas we talk to the Newborn Screening and Molecular Biology branch. Our contact is Carla Cuthbert. She's awesome.
Yeah.
Hi again. I guess it's my turn to talk. So with my experience here and being thrown into the newborn screening world, I only had like a couple of years in grad school for my bioinformatics experience, but that was more on microbiome studies. So I wasn't keen on not keen, but I didn't understand what it meant to be a part of a newborn screenings group and how bioinformatics would work in that area. So I thought this would be a good way to talk about like utilizing the resources you have and there's expertise within your laboratory to figure out or answer the questions you might have, or if you're given a project, what you might find you would have to do. Again, this is from my experience, and like joining StaPH-B would be awesome and adding on to the connections that we needed. Oh, next slide, please. So this is a scenario, wasn't invented. It was just something, for example, with Bob's project, which is adding a third tier to the cystic fibrosis screening, where I interviewed him very low key and asked him a couple of questions about how he went about doing his project. And this was pretty much the breakdown of the steps he took, which was first, like talking to the staff running the panel and understanding what they see might be the issues with the panel or where there could be improvements in place. And then from there, determining the goals that you might set. For example, decreasing false positives. I know Gretchen mentioned that before. False positives in newborn screenings can be very stressful for parents. And stressful, it's time consuming, costs money, and overall a very big experience for both the parents and for the geneticists to go through. And so with, for example, cystic fibrosis and adding a third tier, the whole goal was to reduce false positive and false negative rates. And so just to, I guess, from there, doing literature searches, outside newborn screenings and how it relates to cystic fibrosis. You can find correlating papers. Yes, some might be in relation to newborn screening, some might be in relation to next generation sequencing, some might be related to exome sequencing, and some might be related to Archer analysis. But it's very hard to find a paper with all those combined. So you actually have to like pick and choose your papers and figuring out how it relates to your project and such. And then from there, establishing a plan of action. And of course, the most important part would be like finding the expertise to help you write and execute your plan of action. For example, with script writing and understanding what you would need to figure out to do. And then of course, you're making sure to cross-check yourself. I know as bioinformaticians, that's like one of the major things that we try to do is to always cross-check and do our sanity check on the data set that we're working with. So that's a little scenario of what someone in newborn screenings would have to go through if they were to add a new tier to their algorithm. So this slide is all about who we would go to if we were needing help in, or if we had a question that we needed answered. Of course, there's the state's infectious disease groups, your university partnerships, CDC APHL fellow like me, although I need help a lot too. Other state newborn screening bioinformaticians like Gretchen and Sam, your AMD regional bioinformaticians, and then your agency's IT group. The IT group helps a lot. Then again, they also take a lot of time in helping you. So I try to avoid them as much as possible. Not saying that they're not awesome in their own way, but yeah, it takes a long time for them to do what I need them to do, and it's better if I do it myself or ask someone a shortcut. But yeah, that's pretty much it.
I just wanted to jump in here really quickly. We have a few minutes left before the top of the hour, and so I just wanted to let anybody know that if you have any questions and you're not able to ask them after the call, I will stay on until the questions are asked, if you guys are able to stay on. But if anybody needs to leave for anything else, can we email you guys questions and you guys will be able to answer them?
Yeah.
Okay, perfect.
And you can put them in Slack too.
Yeah, okay. I'll let you guys finish.
Yeah, and I think we just have this slide here, but I think, a lot of that this is similar with infectious disease. Is kind of a lot of us have to kind of answer this question in our own labs. Is bioinformatics is new, some might say it's trendy, but why is it more than just a trend, and why is it important, and why is hiring a bioinformatician for your newborn screening lab beneficial to your program? And what does their role look like in the long term? And so this slide just kind of reiterates some of what we see as our long-term responsibilities, and within a lab. I guess we can continue with this. Do y'all want to go through this, or do we want to switch to questions?
You just want to do questions?
Let's do questions. I'm leaning towards questions. And if anyone has questions about the slide, we'd be happy to answer them.
Well, I have a not a non-question, more of a comment. First of all, I really appreciate this call, and just pull us out of the COVID purgatory a little bit, at least for an hour. So I don't want to divide sort of like newborn screening bioinformatics versus infectious disease bioinformatics. It's all bioinformatics for public health. So I think we're all in this together. Also, the comment is that it basically illustrates me how much stuff I still don't know about newborn screening. I think this is a great sort of like opportunity to start a more of a webinar series. Because the only things I'm familiar with is cystic fibrosis, and that I don't know a lot about other genetic diseases in terms of the sample goes in and what kind of workflow it went, and what kind of like sequencing process it went, and what's the follow-up process looks like. So if I can propose, I think it will be great if we can even list out one or two diseases for every session, and if we can get into the nitty-gritties of all of this, I think that would be great, especially for some states that'd
be really cool.
Yeah, utilizing bioinformaticians or staff members to serve as infectious disease as well as newborn screening. And then I guess questions for any of you three panelists. You mentioned about the large volume in terms of infectious disease is doing 5,000 per year, while newborn screening is 15,000. Are every single newborn baby is going to go through the sequencing process, or is more like a reflex or second tier?
So go ahead.
Sequencing can cost a lot of money, especially with running that many samples. So we set it up in the way with there, for example, for cystic fibrosis, there's tiers for that way in order to rule out the ones early on to save time and money. So for example, first tier would be screening, and then first tier is about screening, then second tier is about second tier is also screening, then third tier is sequencing. So that's how we run things.
Okay. So if I understand this correctly, the volume will not as big as 15,000 per year in terms of sequencing. It's just the specimen itself.
No, right now it's a lot. It's significantly smaller. So in Virginia, we screen almost 100,000 babies a year. But let's see, for the 2 disorders that we're sequencing for, since we started 2 years ago, we've sequenced 1,500 babies. So a lot less, but that's only for 2 disorders. So we're definitely looking at, as we start adding sequencing for different disorders, that that throughput's going to increase significantly.
Okay.
Ours is a little different on a 2 screen state, because
Yeah.
so we screen 400,000 babies a year, which is 800,000 screens since we do it twice, but we will only do sequencing on 1 test, and we will only do it if they make it to like the 3rd tier. So we do 800,000 samples a year, but we sequence about 15,000.
Yeah.
That's still a lot. I mean, compared to the population in Texas.
Oh yeah, we have like our whole, we have our own like DNA lab area for newborn screening.
Okay.
Yeah. Well, you have sequencing for how many disorders did you say, Sam?
All the hemoglobinopathies, VLCAD and XALD, so 3.
Yeah.
Well, we call the hemoglobinopathies 1, but
yeah,
it's a lot. Yeah, it's still a lot of sequencing. We need to get better about what makes it to our sequencing group.
I think we all do.
All right, thank you.
Hi, this is Alankar from the State Hygienic Lab in Iowa. And I have a couple of questions related to the follow-up portion of newborn screening. So I'm assuming that all you guys have the labs, all the 3 labs that you work at have some kind of follow-up staff that, you know, contacts providers, and if a baby's positive, and to order confirmatory testing and that sort of stuff, or maybe it's not done as much. But Sam, you talked about possibly spending something like 6 hours on 1 mutation, for example. So for the time-sensitive follow-up activities, how exactly does that play? You know, because that's the first question. So how exactly does that work with the time-sensitive nature of newborn screening? The second question is, after switching to next-gen sequencing, did you guys have to train your follow-up staff to interpret the results in a different way, or were you able to keep the language that goes out to people the same as it was when it was, you know, the traditional way of newborn screening? So,
I can talk about it. You said you're from at the Iowa lab, right?
yes.
So Iowa's weirder than most states because the follow-up staff is at the hospital, because Iowa has like the one big hospital. So all of their newborn screening follow-up staff and all their geneticists sit across the hallway from each other. So you can just shout at each other. It's actually really nice. I kind of miss it. But for the time critical disorders, if you get a really high first tier, it's going to go out to the follow-up staff before the sequencing comes back, especially for like like Pompeii and MPS1, like they're doing in Virginia, or like VLCAD and XALD. Those aren't as time sensitive. So like if we don't get to it for 2 weeks, like it's not a big deal. The time critical disorders that you need to catch within like 48 hours, those are all molecular based, and those will go out immediately. So for if there were like any reason that one of their like molecular test for the diseases we screen for came back really high, that would get sent to follow up first. We didn't particularly have any issues switching from next gen to Sanger, or from nothing to next gen, because our follow-up staff and our genetic counselors and our geneticists are involved in every step. Like we have like quarterly meetings to be, okay, what are we giving you that you don't want? What are we not giving you that you do want? What language do you want to see? And then they were able to provide training for interpretation as well. So for us, I guess that wasn't a huge issue.
So are you saying that, go ahead.
Oh, I was just going to add that I think in Virginia too, I think that our follow-up, there was a significant amount of education of our follow-up nurses on, you know, the specifics of sequencing and what we were able to identify and not, what are the limitations, what can we say about it, what can't we say about it. And I think that that education surprisingly had to be passed on to our specialists too. Not that they didn't know what sequencing or genetics were, because that's what they do all the time, but I think it was just in the context of screening. And, you know, it's a little bit different when you're looking at a baby where they didn't come to this situation because they had symptoms and they're doing diagnostic testing. A lot of times, you know, some of these babies, they look healthy. They, and it's how educating them and working with them. I would say a lot of times it's a back and forth education too, so that they know how to handle these individuals and these families and communicate with them on, you know, their baby that they thought was healthy.
Okay, so Sam, are you saying that the time-sensitive stuff is not done through next-gen sequencing yet? It's all traditional testing, molecular testing, basically?
It's all time sensitive to a point. Like we all have really tight turnaround times, but it's not like for some of the metabolic disorders, like if you don't catch it within 48 hours, the baby's gonna die. The diseases that we're sequencing are not those diseases. They need to be caught within probably like 3 months. I know we shoot for sequencing, our turnaround time is 10 days is what we shoot for. But yeah, the ones that are like fatal or need treatment within a couple of days is not what we're sequencing for.
Okay.
Yeah, and with those time-sensitive disorders, typically, like Sam said, follow-up is contacted and communication with families occur before sequencing happens to get babies in to try to, you know, do additional monitoring while they're waiting for the sequencing. And in the addition of bioinformatics and next generation sequencing, the hope is 1, 2, that 6 hours to interpret a variant is expedited with adding in, you know, informatics and bioinformatics. And then also, you know, it's just because our screening results may take a little bit longer for us to report, the overall looking at that diagnostic odyssey is shortened because we're able to give them more specific information on the specifics of the baby genetically.
Because otherwise they would have to get our result, make an appointment with a geneticist, which can take 3 months to a year, see the geneticist, get blood drawn, have that sent out and send back, and then start your diagnostic. Whereas when it comes from us, they go to the geneticist with the mutations in hand, and that can shave months to a year off of their diagnostic time.
A lot of these disorders still need sequencing and genetic evaluation in order to achieve a diagnosis. So we're expediting that by doing that on the front end as part of the screen. Okay.
All right, one last very short question. I'm hoping, is CFTR still done at your lab through real-time PCR, or is it you? Okay, all right, thanks.
We do real-time PCR. CF is kind of weird because it has so many intronic variants. So that's always when we're talking about switching to whole exome. It's like, all right, but what are we gonna do about CF?
Yeah, Virginia, we're talking about doing NGS, so amplicon based, kind of evaluating how that would benefit our program. But CF is one where I think states vary so much by what tests they're doing.
That one's really population based too.
Yeah.
I had a couple of questions while people are still thinking about it, and if they have any other questions that they want to ask. But so I'm curious to know, when you're doing kind of like the the mapping of sequences back to like a reference genome, what is the reference human genome? Is there like a specific one that we've just decided like this was the healthy person, so like we're gonna, you know, compare it back to this one? Or is it kind of like a composite of like, okay, like based on all these different things, this is kind of like the amalgam reference genome? I'm just curious.
Yeah, well, so there's different versions of the current human reference genome. I think the most recent one, I don't know if there's, but the one that's on primarily of the data sources is the GRCH38. Yeah, so I guess someone else can add into if they've got specifics, but I don't think it's based off of an individual. I think it's based off of,
amalgam.
Yeah, kind of looking at the best description or of what it should be to try to, you know, all of us will have various insertions and deletions and at varying frequencies. So it's trying to account for the best description of the human genome. And there's different versions of it. So when you're looking at variants and you're comparing information, you always have to consider what reference genome it's in relation to.
And so I guess that kind of leads me into my next question is like, what is the kind of threshold or confirmatory process for determining whether a mutation is something that needs to be looked at? Like, so you guys have just kind of like a set of mutations that you're comparing against that, you know, like these ones are pathogenic and then these ones are benign. And then if you find something that's novel or like that hasn't been seen before, what do you do in that kind of case?
It varies by disorder.
Okay.
CF, and it depends on, varies by the assay. And Jessica can probably add because, you know, Newark does something interesting with this, but for lysosomal storage disorders, we're not looking for specific mutations. We're looking for all mutations in the targeted gene, and we interpret those, trying to identify which ones from the information available, which ones are pathogenic and which ones are uncertain significance. So we have majority of our variants are uncertain significance. So we're not looking for anything specific in that instance, but it varies with, it's different with cystic fibrosis.
Yeah, it's interesting because human genetics is, I think, a little bit more complex when you compare it to other areas of biology. But like Gretchen said, if you have a region of interest, there are some variants that are common within the population, so you could rule those out. And then there are a handful that you might think might be an issue, but then you go through different databases and you compare your results with the results from the multiple databases here in New York. We don't just use one because
we use this entire list of databases.
Databases and we compare, and I think we have 3 geneticists, well, 3, the director along with my mentor Denise, and then one more person. They actually do a whole interpretation process on a variant, and they check off using those lists of databases to figure out whether they consider that particular variant to be benign, pathogenic, likely pathogenic, or variant of unknown significance. And then we have this really, really large database of collected variants that have sorry, I get corrected all the time here, variants that have been interpreted over the years and have been uploaded to this database. It's Excel, by the way. It's a little slow because again, we don't have.
That's what ours is too. So
it's lagging so bad, guys. Of like an entire like hundreds of thousands of variants and collected numbers and such from each database that we've used over the years, along with an in silico verification that I do. And yeah. And so if we see it again, we can say, oh, we know what this is, check, and we can just, it saves times over the process. If it's a new one, we add it, and then we do a second verification. And then once, if we see it more than once, then we bold it to make sure that we can say, okay, this is a confirmed variant of whatever, quote unquote, likely pathogenic, or benign, whatever you call it is. So yeah, it's a process.
And the American College of Medical Genetics, which is what the geneticists, the genetic counselors in the lab all use to make these determinations, has a list of like, this is reason A, it would be pathogenic, or this is, I think it's numbered, reason 2. And so like in our form that we sent out to geneticists, we're like, we used reasons 1, 7, and 9 to make this decision, and this is where we got those numbers from.
Yeah. I think what's also interesting too is that different disorders have, I guess, different levels of curation of their variants too. So CFTR, they have the CFTR2 database where, you know, a lot of states, when they see a variant that's within that database, they go by what the CFTR2 database says. And if they kind of use that as like a first pass. And then if they do open up to look at more variants, that's when if it's not in that database, they will interpret it on their own. But CF is a really interesting disorder because they do have that well-curated database. You know, there's different ones for different disorders, and those are curated at different levels and taken with, you know, some of them are just used as criteria to influence our system or decision, while others are, you know, what they say is what the classification is.
Thank you. All right, does anybody else have any other questions? I know we've taken up quite a bit over the hour that you guys so graciously gave to us. So thank you for staying on and answering all these questions.
Thanks for listening to us.
It's a lot of information to pack into an hour. So.
It is, yeah. And I think, you know, to Sean's point, that was something that we had kind of actually even discussed a little bit before this call too, was, you know, maybe having this as be kind of the first introduction, and then going into some more specifics about newborn screening and some of the different areas in later calls, and maybe having I know that you guys are extremely busy, but we could potentially revisit that and have some sort of, you know, ongoing kind of call schedule, because it sounds like there would be interest in that. So
busy, but we do like talking about newborn screening. So
all right, well, I'm gonna stop the recording.